the battery can be designed either for a higher energy density, so more energy in a smaller space, but then they tend to be less thermally stable, or they can have a lower density and more stability. And the chemistry within the battery affects the charge and discharge rates. The amount of capacity of the battery, I've got another slide of that, is dictated by the amount of electrolyte that there is in the battery. So the amount we have here dictates how much charge you can store in the battery. So if you have a battery where there's not very much, these two plates are effectively very close together, then that means that you can get lots of power out of that battery because you haven't got very much internal resistance, but you get less capacity. Or you can move them apart, you get more capacity, but you can get less power out. The problem for the electric car makers is they want both. They want mileage, which is capacity, but they also want power because we all like to drive fast. They don't want a vehicle that's going to be sluggish, so they want to get lots of power out of it. So what they have to do is they have to over-design the battery so it can do both things. So we can split the lithium-ion cells into these sort of two classes. There's the high power and the high energy, and they all have different charge and discharge characteristics. They all have to be charged at the correct voltage, and they don't tolerate overcharging. Well, the nice things about lead acid, if you overcharge it, it's not a great thing to do to a lead acid battery, but all it will do is just do a bit of off-gassing. If you overcharge a lithium-ion battery, then you're into a whole world of woe. Everything from it exploding to bursting into flames. And so that means that there has to be much better charge control of the battery, especially if you're using a renewable energy source, which is jumping up and down all over the place as the clouds go across the sun.